Remember, if you haven't taken it, you gotta come in Thursday morning and do so. We are gonna talk about now parametric equations. So if you get out your notes, on the back side of the 6-2 sheet was 6-3. And let's go ahead and start with our calculators. So you want to get your calculator out? And so that we have a common base of conversation, let's go to mode. Let's be in radians. Now, we don't have to be in radians. I just want us all to be in the same thing so that we can have a common conversation. So we're going to be in radians. We could be all in degrees, but we're going to be in radians. And you need to put yourself in parametric mode. So, on my calculator, I don't know if they're all the same, right under where I pick radians and degrees, I have options in function, parametric, and so on. I want to be in parametric mode, PAR. Everybody find it? Okay, now I want to go to my window. And now things have changed a little bit in the window because now you have t's, and that's because we're in parametric mode. So we're in radians. So let's go from 0 to 2 pi. Anybody want to take a wild guess while I'm picking 2 pi?
Full circle.
That's a revolution, right? Now, if I were in degrees, I would probably be going from 0 to 360. Does that make sense to everybody? Okay. Now, let's see. For t step, now let's just talk about this for a second. If we're only going from 0 to 2 pi, and 2 pi is about 6.28, if we're only going from 0 to 2 pi, then, so we're only plotting points from 0 to 2 pi. What do you think that our increments should be? Something pretty small, right? Let's try 0.1. And then for now, for x min and max, let's just go with the standard window, -10 to 10. You need to do that for x's and y's, -10 to 10. You may need to adjust that. I don't know what these pictures look like. Okay, everybody's set up, ready to go? All right, let's type in an equation. Now you will notice that when you type y equals, it now is asking you for an x and a y. So let's just put in the first one right off the page. X equals 5 cosine t, and your t is on your variable button, the same place your x is. Now when you press it, instead of getting an x, you're going to get a t. And then y is for sine t. Hit graph and let's see what we get. Actually, mine looks like an ellipse. An oval, that mathematicians would call that an ellipse, but yeah, it's an oval.
Wait, I didn't get it.
Probably because you didn't press the buttons that you should press.
I didn't see that.
It's at a restaurant.
I was thinking. I know. The greatest part of my life. Well, not
It's like a detour there. There's a construction about.
not exactly. There's one next to cheeseburgers.
Thanks for earning it.
Yeah. And Okay, it's basically, it should be B. But anyways.
Okay, now,
We're gonna go there.
let's go on to the next one. Let's go ahead and clear out these equations and let's put in the next one and see what we get. Remember, when you put, the next one has a squared in it. When you put that in, you're going to put 4 sine t squared. You're going to put it in like that. Might be something kind of weird looking. Yep. Looks kind of like a line going up this way. Or I guess the way you're looking at it, going up this way.
What was cosine? I don't have paper.
What do you mean, what was cosine?
Like we're plugging into the equation.
Look at someone else's paper. Nobody in the back row has a paper.
No.
Now, I want to caution you, we're going to turn our calculators off now, but it is set in parametric mode. So if you get it out and you want to graph a y equals equation, you're going to have to go back and change it into function mode. It's set in parametric mode now until you change it back out. Okay? Now, the next directions say, okay, I know I could graph this on my calculator. I just graphed something like that. I could do that. But without the calculator, I want to figure out what this looks like. Like the first one we graphed was an ellipse. The second one we graphed was that weird thing. Now, what does this one look like if I graph it? Well, we're not going to graph it. We're going to eliminate the parameter. Now, I think we did something like this earlier. Anybody remember how we might eliminate the parameter? We're going to substitute. That would be one option. So, in other words, t equals y minus 5. And if, from this equation, everybody follow that? So if t equals y minus 5, then we could say x equals 2 minus 3 times y minus 5. And x equals 2 minus 3y plus 15. Or x plus 3y equals 17. What is that? There's no more parameters, so we took care of that. What is that the equation of? That's not an ellipse. What is that? That's a line. This is a line. So the directions said eliminate the parameter, done, no more t's, and identify the curve. It is a line. Now just for fun, type these equations into your calculator and see if you get a line. So 2 minus 3t and 5 plus t. Did you get a line, or at least part of a line? Any idea? Never mind. Okay, let's look at the next one. Do the same thing. X equals t, y equals t squared minus 3. We need to eliminate the parameter. Any idea how to do that? Just put x in for t, sure. X is t, so y equals x squared minus 3. What shape is this? That's a parabola, isn't it? That's a parabola. So these are the parametric equations for a parabola. And this, of course, is a regular, rectangular, or Cartesian equation for that parabola. One more. Ooh, this one's a little harder. this one is tricky. Any ideas how we might eliminate this parameter? Get t by itself, we'd love to do that, but that's going to be hard because we don't really have a t, we have a cosine t. So x over 3 equals cosine t, that's true, right? And y over 3 equals sine t, that's true. Well, I could eliminate if they matched, but they don't match. And I can't change sines into cosines. Andrew?
Or, so you could find the force of one, and then you see x and y, it's just x and y.
I think I see where you're headed. Let's do this, so it's more mathematically based and not quite so intuitive. I think you're on the right track. What if I squared both sides? Now, that's perfectly legitimate. What do I end up with if I square both sides? X squared over 9 equals cosine squared, and y squared over 9 equals sine squared. Now what happens if I add those two equations together? I just add them. I get x squared over 9 plus y squared over 9 equal to 1.
Ooh.
Oh.
Didn't see that coming.
How did we get rid of that parameter? We turned it into an identity. So cosine squared plus sine squared is 1, so we have x squared plus y squared equal to 9 if we multiply to clear the fractions. What shape is that? No, it doesn't go like that. It's a circle. This is a circle. Where's its center? No, at the origin. And its radius is 3. So these equations, put them in your calculator, graph it. You're going to get a handy dandy little circle centered at the origin with a radius of 3. Does anybody's look a little bit like an oval? Now here's why. This is kind of a quirky thing about your calculator. What shape is the screen on the calculator?
Square.
No, it's not a square, and that's the problem.
Parallelogram.
Rectangle.
It's a rectangle.
Yep.
So what happens is, when you say your window is -10 to 10, it stretches a little bit one way over the other because the screen is not a square. So
try to
if you
trick
go
us.
to Zoom and click down to Zoom Square, then it will actually square the screen and you will get a more accurate picture. Okay, then it will become, well, it is a circle. So if you square the screen, you'll get a circle. You're not going to get a circle on your rectangular screen because it was pulled horizontally, because the screen itself is built that way. Okay? All right. Next. Write the parametric equations of the line through these 2 points. Okay, now wait a second. This sounds hard. back up to 2A. We already did this. We eliminated the parameter and found out this was a line. Do you remember? We did this one already. This is a line. So now I kind of just want to work backwards from this for a second. Another way of writing this I already know is a line. Another way of writing this would be maybe like this. Now before you say anything, I want you to kind of just look at what I've done and see if that makes sense to you. I want you to look at the first part of every parenthesis. X equals 2 minus 3t. And then y equals 5 plus t. Do you see how I've taken the two equations and kind of consolidated them into one? This equation, the single equation, represents these two equations. X equals 2 minus 3t. Y equals 5 plus t. Okay? So I am shooting for, before I can get to this, I need to get to this. So I want to take these 2 points and somehow write them in this form. I'm going to put my X and my Y here. Now I need to know what to put in those blanks. Now, one of the 2 points can go here. It doesn't matter which one. One of the points goes there. I want you to think about what's happening here, though. If I plotted a few points, if I let t be 0, I would get the point 25. Okay? If t is 0, I get the point 25. Now what happens if t is 1? I'm just plotting some points. So if t is 1, I get -1, 6. If I put in 1. Now this was the point 25. This is the point -1, 6. How did I get from here to here? What did I do? I backed up 3 and went up 1. Now do you see that anywhere in this equation, backing up 3, going up 1? Do you see that anywhere?
Yes.
That's right here, right? So what goes in that second parentheses? Not another point. You don't put a point in there. What goes in there?
Slope.
The slope of the line. How do you get from this point to this point? You backed up 3 and went up 1. So how do I get from this point to this point? Wait, from -2 to 8, or from -2 to 6 is 8, and from 4 to 1 is -3. There is the equation of your line. This is your starting point, and you can use either one, it doesn't matter. And then this is called the direction vector for the line, and it's the equivalent of the slope. It tells me how a line moves. I need to get from this point to this point, so what do I need to do? I need to go forward 8 and down 3. So what are my parametric equations? X equals what? -2 plus 8t. Perfect. And y equals 4 minus 3t. There are the parametric equations of the line. That easy. What goes in this first blank, or the first parentheses, when you write your equation, what goes in there? A starting point. You can use either one, doesn't matter. What goes in the second parentheses? Not a point. What goes in there? The slope. So if we are going to repeat this problem for 1, 1, and 2, 3, here we go, quickly. Our equation is going to look like this. wanna put in this first parenthesis? 1, 1, great choice. What do you wanna put in the second parenthesis? 1, 2. How did we get 1, 2? It is the vector from here to here. 1 to 2 is 1, 1 to 3 is 2. So what are the parametric equations then? That's not the parametric equations. The parametric equations are x equals y equals. What would that be? 1 plus t, 1 plus 2t. Perfect. Those are the parametric equations of the line. We will continue this tomorrow because we've got a little bit more to talk about. Don't forget, I need your permission slips. Have your parents email them or bring them tomorrow, please. And Mathlete t-shirt order forms. Take care of that so that you are sure to have one. All right, John, can you turn this off? Thank you. Have a good